What's going on YouTube? This is Ipsec, and this is a video series I wanted to do for a long time. However, I just didn't know how to do it responsibly. That being said, I think there's a lot more of the commercial C2s coming into play, and it makes it really hard to understand what they're doing. And if you're not ready for it, it may blindside you in the future. So I decided to put together a series, or at least start a series, on building small components of the C2, not the C2 itself, but if we break it up into small chunks, we'll be able to understand exactly how it works under the hood, hopefully build detections or learn how to reverse it whenever we do come across it. So in this video, we're going to look at how people may bundle configs in an actual executable so the operator can change it out without having source code to that executable. I call that malleable agent config. I'm not sure if I'm using the terminology correct, but that's what we're going to call it in the video. It's all going to be done in C++ because that's the only language I'm really familiar with that doesn't involve some type of embedded virtual machine. Learning Rust is on my to-do list, but for now, we're just going to stick with C. With that being said, let's jump in. Before we go into showing a live demo of doing some coding with some malleable C2s, let's just start off by showing how they work in the wild. And of course, the very first one we're going to pull up is Cobalt Strike. So we're going to search Malleable Cobalt Strike and go to the C2 Profiles GitHub, and we can take a look at one. The meterpreter.profile is a good example, and we can see various things. So the default sleep time is 100 milliseconds, so this is a very noisy one. We can see the default spawn 2 is going to be notepad.exe. This is probably a bad one to do because not many people target Notepad. If this was a real op, I would probably expect to see it in werfault.exe, werfault. That is the error handler for Windows. And also gpupdate.exe is another big one. But being able to extract this information from the beacon that you find in your environment is super handy because now you know exactly what to hunt for. And you can get a bunch of other parameters like the user agent it's going to be using, but being able to extract the config or the malleable C2 profile from the beacon is super handy. I can show you one that I use. I can't really pull up Cobalt demos live because I don't have a copy of the software, but kind of how I use the malleable C2. And I'm not sure if I'm going to be using this terminology correctly. This is just what I call it. So I'm going into stage 1 I have. This is based off of Silent Break Securities course. It has a fork. I have a lot more features in it, but the actual layout is from them. But we can see various config options. So if I go and download Scattershot, I'm going to do curl-k-o. I'll call it test.exe. And then we'll do navi.dev files scattershot.exe. So I download it. And if I do a strings against this, I called it test. I don't see any of these parameters because it's all XOR'd in this, which we're going to go into later in the video. I'll show how I did the malleable C2 part of this. But I'm going to do grep-i, navi, and we don't see this string anywhere in here. Now, what I'm going to do is we're going to put this with 4 A's and download it again. So 1, 2, 3, 4. And I'm going to save. And I'm just going to go back up here, try to download the same exact thing, test2.exe. And now we're going to do a hex dump of both of them. So test.exe to 1.hex and test2.exe will go to 2.hex. And this just lets us do a quick diff, and we can see exactly where they differ. Now, this is going to be the C2, the actual config. And what I'm going to do is go into CyberChef and show how to pull it. And this is a super simple sample because I'm just doing a simple XOR. And if this doesn't make sense, it hopefully will by the end of the video. So this is just doing a live demo to kind of show the value of it. So from hex dump, we paste this in and get rid of those. And then we can say XOR. Let's try XOR brute force. Does this work? And we're just scrolling down till we see something that we want. Let's see, did this get it? I've never used XOR brute force in this. Oh, this is doing 2 byte keys. Key length, wait, key 1, 2, sample offset, known plaintext key. Oh, come on. Scheme? I was trying to, let's see. It should be 51, I think. Yeah, there we go. It did brute force it. So if we're looking for strings, we have it now. We did an XOR brute force. It's 51. I kind of cheated because I knew that because I wrote this piece. But if we just do an XOR now, and key is going to be capital Q, and we change it to UTF, now we can start getting the actual C2. So I'm going to go to this spot in the hex dump. So let's do less 1.hex, paste this, and I'm going to grab a bunch of data. And now we can start pulling back pieces of how the config is written. So this is going to be super helpful because now, like, if you do this in your implant, it's a way for you to modify a bunch of parameters in your actual executable without giving the source up. And if you're like on the blue team watching this, I'm going to do some light reverse engineering after we do it so you can kind of try to piece together how to pull apart a C2 that's using a config like this. So with all that being said, let's just jump in and do the coding. Before we get into anything complex, I'm just going to create a simple hello world. So first we need to include IOStream so we can do a print statement. So int main, or cout I should say. So standard cout, we need to direct, please subscribe here, put a line break. And if I compile this, we'll call it C2. All it does is print please subscribe. So the next step I want to do is I want to take this string and put it in a separate file called config.h. So we can do std string config buffer is equal to thank you. And I want to make that a constant. Save that. And over here, we can now include config.h, and we'll print this one out as well. So I'm going to do config buffer. So let's compile, and we have please subscribe and thank you. If I want to make sure everything's on the same line, I can just put a line break there. We can compile it again, and we have it. Now, the issue I have right now is thank you is only going to be the correct length. So if I do echo-n, thank you, wc-c, 9 characters. And if I xxd my program, look for thank you, we can see we have the 9 characters and then the null byte terminating it. So if I wanted to modify this binary afterwards, because we can just change any of these pieces of text to be something else, it has to be within this size. So the easiest way I've got around that is I don't use a string here. I'm just going to do a, let's see, static unsigned char config buffer 2000, and we can say thank you. I'm going to say very much. So we save this, compile, and execute it. We have thank you very much. And if I go back to that same xxd, we have a bunch of null bytes afterwards. Now, I could have just padded the string. So if we go back here and comment this one, and I put a bunch of null bytes like this, that would work as well. So save G++, like we have thank you there. If I go into XXD and we look at it, it did put the extra null bytes there. I just really like having the ability to set it numerically because I just think that code is cleaner. So the next piece is we're going to be passing a JSON string in. Now, if I was doing this for an actual implant, I probably wouldn't want to use JSON just because it's a lot of wasted space. But for simplicity of explaining things, JSON works very nicely. So let's now, let's see, we put a bracket and let's just do host name. And this will be please. Let's see, I think that is correct. And we need a probably second thing in our JSON. So this will be migrate because most like Malleable C2s will give you the ability to automatically migrate into a process. So this one will be subscribe. I think that's good. I escaped all the quotes. So when I now compile this, let's see if it works. C2. Okay, that looks good. Let's just validate this is proper JSON. So I'm going to give v main. Let's take this string out. Compile it again. ./c2, pipe it to JQ. And since JQ did not error, we have proper JSON here. So the next piece is we should grab a JSON library. And I use one pretty much for everything whenever I need JSON in C++. Let's see if I can find it real quick. Let's search GitHub. I think this is it. Here. Let's see, do they have a release? I actually haven't downloaded this in a while. Right here. So json.hpp. Okay. Let us now move that into our directory. So cp downloads json.hpp here. And now if we wanted to, we could edit main to use it. So let's include JSON HPP. And then we have to initialize it. So we can call, what is it? Whoops. Where am I? There we go. Let's do nlohmann JSON. Object will be J. And now we have to parse it. So JSON parse config buffer. And what this is going to do is now we can just call items in this JSON like this. So hostname and migrate was the options. So I can do J, hostname like that. And hostname is capital. So let's give it a capital H. Save it. G++ to compile. And if I do C2, we have just the hostname. We could change that and call it migrate, or do a second one and say migrate, recompile, and execute. So we have please subscribe. Now, this isn't the best way to refer to the config. We want to make it a structure globally through the program. So let's not parse it here. We're going to actually create another file, and this one's going to be config.c. So we'll call config.c, and we will call this config initialize. And we're going to pass it a structure, and we're going to create this config t struct in a second. Config. So we're giving it the pointer. So let me just type this out and we can explain it. So standard string, we'll call this config str. There we go. So go up into our config.h, and now we should define that struct. So struct config.t std string hostname std string migrate. Now we do type def, and then we can copy this header over. And let's see, I always hate copying from VI, so I'm just going to less it and then copy it so we have it in our header. Okay. I don't know why that just... Sometimes I hate when it auto does those indents. So let's do comments real quick. Initialize config, and we can say param out config, it's config t, param in config string, and that's a string. Okay, so now we have to initialize the config. So essentially, we just do what we did on the config.h or main.c. So JSON j is equal to JSON parse config string. And we can say config to hostname is equal to j hostname, and config, this will be migrate is equal to j migrate. So that should be good. We'll probably have to include config.h and json.hpp. And just exit that. Let's see. I'm trying to make this look better on the screen. There we go. So now in this main, we can say standard string result, converting the config buffer into a string, and then config initialize conf result, and we want to create that conf object. So config stir conf is equal to new, what do I call it? I think config. Let's do less config.h, and let's see. Did I not save it? That's gonna be sad. config.h. Swear I had more. I guess I did not save it. config.h. Let's see. config.c. Let's just retype it. So I need to grab this header. config.h, delete that, and we need to struct config t string hostname, yank that, name this migrate, okay. Type def struct config t config, There's no way this is going to work. Okay. Config initialize. Conf result. So now if all went well, we can do cout conf hostname. And anywhere in our code, we can pull the host name via that variable conf to host name. So if I do g++, let's see, config initialize something errored. Probably have to do config.c there, give it both files. And let's see, v config.c include IOStream. I don't think we have to do that there. String and namespace standard does not have type. That's probably config.h we have to. Include IOStream. Do we have anything else there? Don't think so. So now our C2 works. Or not, it's not a C2, I guess. But now we have the malleable C2 piece done. So if I also wanted to, we could say, put a space there and conf to migrate. G++, execute, and we have please subscribe. So if we look at it, we can easily see that the JSON string exists, and then we have a bunch of null bytes afterwards because we defined it to be 2000 bytes. So the next piece is we need to create a Python script to quickly be able to replace these variables to make use of the malleable C2. Otherwise, we're just like hard coding variables and that's it. There was no point of doing this. The whole point is to code something that can like patch it. So let's do import JSON, and then let's create a JSON string. So config is equal to nothing, and then config hostname is equal to, let's just call it ip. And then the next variable we'll do is migrate, and we'll call this one sec. And if we print json.dumps config and execute, well, we want to execute the string, so python3 patch.py, we can see we've outputted the JSON string. So now we want to get this into our program. So I'm going to go back to XXD. Goes around 36280, and we're going to copy the string because this is the string we want to find because it's the beginning of our config. So let's go back into patch, and then we're going to find that string. So with open C2, or I did not mean to close that, read binary as bin file. Then we can say byte data is equal to byte array bin file.read. So now we've just read that whole binary data. We can close it, so bin file.close, and now we can find the offset. So offset is equal to byte data.find, and paste in the string we want. And if I print offset, it's going to give me a number, hopefully, right? 221824. So I'm guessing at that index, this is where the string starts. So now let's just reopen this file, but this time with read write. And then we can do bin file.seek to the offset. So now our cursor is right at the start of the JSON. And we can say bin file.write, and then the config. So what we have to do here is say config is equal to that, and we call patch.py, and the config wants a byte value, so we can fix that with just adding a .encode. And if we go to execute it, we have an error. So I'm going to look at what we wrote, and we see what happened. So in C, we got these strings terminate by a null byte. And because I did not calculate like all the padding and we didn't like erase this, it's reading this whole thing as a string. And the JSON library is buffering because it's getting value after where it should close. Now, we could do a bad fix to this and say plus b \x00 to put a null byte afterwards. So now, even though we have not cleaned out everything, we put a null byte, so this terminates the string read. So the JSON library should be happy because it's going to read up until this byte. So let's do /c2, and it is. But I'm not happy. I don't like leaving that junk behind. So let's calculate padding. So I'm going to get rid of this, and we're going to say padding is equal to \x00 on null byte times the 2000 bytes we have minus the length of the config. And I'm going to say we have to close that. We can say config is equal to config plus padding. So now when I run this, we can xxd 36280. We now have successfully erased everything afterwards, so it's just a little bit cleaner. So the next piece of this puzzle is we have to encrypt this because we want to prevent ourselves from being in strings, because that's never a good thing. So if we just like string c2 and grep for ip, we can see the entire config is here. So let's XOR it. So I'm going to create a XOR. I'm going to say we'll just hard code the string. Again, probably something you should do a bit better of a job, but I'm not going to worry about it. So that will be each character, and we want to XOR with a capital Q. I don't know why everything uses like a capital Q to XOR, but I see that more often than not, so I'm going to replicate it. And for list comprehension, we can do for I in range 0 length of data 3. There we go. And let's see, config XOR config there. Python 3 patch.py invalid syntax on config. So that looks like an extra parenthesis. Okay, there we go. Let's xxd 36280. So now this looks to be encrypted well. The downside to this, though, is now we're not going to be able to just run it again because we've encrypted it. So it's going to be really hard to do the find string. We could, because it's just a static 1 byte XOR, we could just search for the string and do it, but I'll leave that exercise for you. Now we have to edit the C code. So the fun part of the job. So let's edit main.c, and right at here, we're going to create a new thing to decode it. So we'll call it XOR, and we're going to, I guess, call this encoded string. And then there we go. So standard string, decoded string is equal to nothing. So we're just initializing that. And then int key is equal to, let's see, man, ASCII Q, that is 81. We want the decimal value. So if we go all the way up, decimal is this one. So 81. Now we want to loop through every character. So C is equal to string pointer to that. Okay. And then decoded string plus equals C XOR'd with the key, and then modulo 255 to make sure it is a byte. So if our XOR goes over 255, it I guess rotates back to 0. Forget the correct word. It's just like, I don't know. Modulo. You should just Google modulo. If we go to like ipsec.rocks, I'm sure I explain it. So modulo modulus. There we go. This is what you probably want to watch. Obscurity right there. But let's finish this program. So after this, we want to return decoded string. And now the issue here, though, is we don't want to un-XOR all our null bytes. Because if we do, then they're no longer null bytes and they'll be read by the parser. So we want to put a breakpoint in. So if C is equal to -1, break. And then in our Python program, I think we just add a FF. So let's change this padding down 1. So 1999. Or actually we can leave 2000 and then I'll add -1 because I'm adding 1 byte in this config. So right here, I'm going to do B \x FF. So that should match that -1. Okay. Here goes nothing. So G++, we're going to compile everything and unqualified ID before XOR. V main.c. Oh, I wonder if I can't use XOR. Let's see, let's call this decrypt _ XOR. And I'm probably going to get like it's defined but not used, which is fine. Oh, didn't even get that. But I realized I did not put it in my program. So decrypt _ XOR. And we put it right here on the config buffer. So before we send it to the config initialize, we're going to XOR it to try to decrypt it. So let's hope this works. Looks good. Now it's going to fail here because we have not ran a patcher, right? Because if we now xxd 36280, it's still plain text. So let's do a patch. So Python 3 patch.py. That looks good. 36280. It is encrypted, and then we have this FF. So as long as -1 matches that, we'll be fine. Well, and that we like wrote our decryption routine correctly, but we'll see. There we go. So that is that. And if we wanted to, we can now compile this again, and we can edit patch.py and say, thank you very much for subscribing. Please leave a comment. So patch, Python 3 patch, C2, and we have the full program. And now finally, let's just try to reverse it. So I'm going to open up Ghidra, and we're going to look at what this program looks like in a decompiler, and then just use GDB to step through it. I know Ghidra now has a disassembler of its own, but I'm actually not sure how to work that thing. So I'm just going to go with the way I know right now, and we'll tackle that Ghidra built-in debugger in a later video. So I'm just pressing I to import the C2 binary. And this is going to be super easy because it's not stripped. So we should have all our function names and everything there. Let's see. We can go to exports. We have our, in a second, once it finishes loading. We can see in the bottom right it loading. Once it's done, go to exports. Where's main? There we go. Go to main, and we can see the function decrypt XOR. So what we're going to do is switch over to just GDB. So gdb./c2, and I can do a disas main to make sure we can see all this. And I can just break here, run it. And we want to break right on this decrypt routine. So I'm going to break there. We'll continue. I'm going to step into it. And then I'm going to do another disassembly so we can look at this function. And I'm going to break on the return value. So we can break here. And I'm actually going to rerun this because I missed out on showing something I want to run. So we're at the beginning. We go in here. We can look at the strings on right before this. It's moving REX into RDI. If we look at that, it's not what we want, I don't think. Maybe that's the string. Let's see. Run it. Let's see what it's doing. So this is building the stack. And we're at the decrypt now. Oh, RSI. RSI is the argument that's passing. So we can x/s to examine string on RSI. And yep, this is the XORed string. So if we go back into the XXD output of our C2, was it 32680? That's not where it is. Let's just search for a lot of null bytes. Let's see. 680. Where is it? I lost where it is. Let's see. We can probably search for *s, maybe. Let's try that. So \*s. There we go. 36280. I think I reversed some bytes. But we can see this string and then like 2000 null bytes. So we know that is definitely the encrypted string. So we step into this and then we do another disassembly and we can break right here. And this is like the best way to get comfortable with doing some type of reverse engineering is you have a binary that you wrote, so you know exactly what it should be doing, and then you just play around in it. So right here, let's see, did we just end on this return? We did. So if I go up here, we should see RDI and the decrypted string. So now we could, if we wanted to, reverse the Python we did before to look for that *s, I think it was, x/s RSI. Yeah, we could look for this string and then pull out up until a \xff and then do the XOR routine ourselves. And if we didn't know what the XOR key was, we can always step in, do a disassembly, and let's see, is it obvious anywhere here? I don't think so. Let's see, unwind. Maybe if we look at the decrypt XOR routine here, look at exactly what this is loading. I'm guessing local 20. I'm guessing that's the queue. So let's do man ASCII, look at capital Q, 51. So when we used we're in decimal, but Ghidra is showing us in hex. So right there, it's loading that XOR string. And then while it's doing a loop, does not equal null byte or -1. Remember, that's the FF we put. It's doing a XOR right here. So we can see local 19. Local 19 is just looping through each character in that one string that we have This is different pane. Let's see, do we have it up here? It's looping through, what is this? So it's looping through each of these characters. So this is 19, 19, probably one character. So it's looping through that and then doing XOR with 20, which again is Q. So this would be kind of how you analyze it. If you wanted to make it tough, and I'm not going to analyze it after we do this. If you want, you can probably check out some of my videos where we do stripped binaries. But if I do G++ and then add the -s flag, this is going to make it a lot tougher, because now when I do like gdb./c2 and I say break main, main is not defined. So we have to find like the starting point. If we want to analyze it real quick, we can open up C2, put it here, analyze, analyze, okay, wait for it to load everything. And what we're going to see, what we're not going to see is all the function names. Like we have a lot less exports because it didn't put that whole table there. So if we want to go to the main, we have to go to the entry and then hit the function on the libc start main. And now this should look familiar. Actually, we didn't run a Python program, so it's not obfuscated yet. So let's run that. Python 3, we called it patch.py. So now we can import C2 yet again. Analyze, yes, okay. So once this finishes, we can go look at that. So export, entry, function. So now it's just a data. If we go into this, here's the XOR routine. We can kind of still see it, but all the names are wrong. So if you want to go play around in GDB to analyze it this way, that would be a fun task to do after the video. But hopefully the whole Malleable C2 stuff has been like demystified. So if you enjoyed the video, let me know in the comments. Take care, and I will see you all next time.